Welcome to the Anxiety Math podcast today. My name is Tao Ling, and I will try to help you understand how to rationalize denominators. First, in order to rationalize a denominator, you have to know what a conjugate is. Usually, when you have when you see a fraction such as this, 2 plus square root of 3, the conjugate of that would be 2 minus square root of 3. Okay? Why is that? Because if you multiply this by that, you can use the special product formula, which is 2 square minus square root square, right? So this would be gives you 4 minus 3, which is equal to 1. Okay, so the conjugate of 2 minus square root of 3 is 2 plus square root of 3. So the conjugate of another one, let's say square root of 5 minus square root of 2, okay, is square root of 5 plus square root of 2. Then this is going to equal to 5 square minus 2, well, square root of 5 square minus square root of 2 square. It's going to equal to 5 minus 2, and then that will give you 3. Okay, so the conjugate is a product that after you multiply it, it gives you a whole number, okay, without any square root. Okay, so, and you usually get it by inverting, keeping the numbers the same but inverting the sign. Okay, so let's try that. And that's the first thing you have to know about how before you learn how to rationalize the denominators. So anyway, let's try to rationalize the denominators. So here's an example: a1 square root of 2. So what does it mean by rationalize a denominator? So it's really just doing so that the denominators doesn't contain a square root, doesn't contain a number with a square root in it. So you want the denominator to be all whole numbers. So 2. So in this case, you have 1 over square root of 2. It's not rationalized because the denominator is a square root. You don't want it to be square root. Okay. So how do you do this? Well, if it's just a square root in the denominator, one thing you could do, remember that you can multiply a number to both the numerator and the denominator, and the value wouldn't change, right? So one thing you could do is you could multiply both the numerator and denominator by square root of 2. By square root of 2. So in this case, the bottom will become square root of 2 times square root of 2, which is square root of 2 squared, and that's going to give you 2. The top will be 1 times square root of 2, which is square root of 2. Okay, so now the denominator is rationalized. It doesn't contain a square root anymore. It doesn't contain a number with the square root anymore. So now this is a rationalized denominator. Okay, that's how you do rationalize a denominator. So let's look at another case. 7 minus square root of 5. Okay, this is when you have to use the conjugate. So in order to rationalize it, you have to multiply both the top and the denominator by the conjugate of the denominator. Okay, so if you do this, you multiply both the top and the bottom by its conjugate, which is 7 plus square root of 5, right? We keep the number the same and we just change one sign. It becomes 7 plus square root of 5. So if we multiply that by denominator, we also have to multiply 7 plus square root of 5 to the numerator. When you have that, this becomes 7 squared, which is 49, minus square root of 5 squared, which is just 5. And the top becomes 14 plus 2 times square root of 5. Okay, so we do that again. It becomes 42 and 14 plus square root of 5, 2 square root of 5. And then we see that we can factor out a 2 from all three numbers. So it becomes 7 plus square root of 5. 42 become 21. Okay, so that's your final answer. So in order to rationalize denominator, you usually have to multiply the denominator. If it contains a square root, you multiply it by the conjugate. So by doing that, you also have to multiply the conjugate by the with the numerator. So by doing that, the denominator will become a whole number that doesn't contain any square root. It doesn't matter if the numerator contains a square root or not. The point is the denominator doesn't contain any square root. Okay. And so that's how you rationalize a denominator. And that's it. And thank you for watching.